Okay, so some of you I know and some of you I don't know. It's fantastic to get to meet everyone. I got to tell you that I think that this will be a different presentation, hopefully. I really do not want this to be death by PowerPoint. I want to reiterate for those of you that came in recently that this is going to be more like an interactive lab. And I actually want to walk you through how to learn this subject, because one of the big frustrations that I've had in trying to get people used to networking is, it's a skill. And much like any other skill, you can watch the Great British Baking Show. It doesn't mean you know how to make bread, right? It just means you know how to sit and watch people do it. So the only real way to learn is to do. And so this presentation will hopefully walk you through how to do. So I want to encourage questions. If there's something I go through too quickly, please slow me down, have me redo it. I'm only got an hour, but let's just see what we can do in that amount of time. So a word about myself. There we go. Oh, went too quick. In 96, actually 95, I graduated from USMIOS in the Army, and that was fantastic. I was actually National Guard biomed, which is a very rare thing. Ended up going back home after my AIT and took a job. And I took a job cleaning film processors, and we talked briefly about that and watched it evolve into, printing, and then printing from multiple sources, and then finally just getting rid of the printer and putting it on a display. And that's really where DICOM came from. At first was DICOM 1.0 when they just wanted it or just DICOM when they just wanted it to print. DICOM 2.0 started to really get into the concept of storage. They did DICOM 3.0 and did all of these additions and features, and it's more like HTML. If you've been watching web browsers, they grow and they evolve and they incorporate new technology. And now they've just gone back to calling it DICOM, and they just do regular routine updates, and there is no 1.0, 2.0, 3.0 anymore. Okay, so I've taught this for 15 years between two different colleges. So, had some time to polish this. So hopefully we're able to go through that. I do currently work for the Dallas VA as an imaging biomedical equipment support specialist. I do not have the VA disclaimer, but they do want me to probably let you know that this is my opinion and not theirs. So please don't hold the VA responsible for anything I'm about to say. Okay, so DICOM, let's just start with the basic definition. They always say that, right? Digital image and communications in medicine. I keep calling it digital image communications. There's an N in there. But basically, it's all about taking a picture instead of an X-ray. In fact, actually, the picture is the X-ray now, right? Not a film. So this is what they call a open source protocol. That means that anyone has access to the structure of it and can make software on it that should be compatible with other people's software. And the concept is that we all just get along. To skip ahead at the bottom, you'll see that we do talk about private data, and that is the OEM secrets. We had to make a proviso for the OEMs, or else they wouldn't play ball, basically. They do have the ability to encrypt and embed their stuff. However, the diagnostic image and the data needed to read it should not be or cannot be encrypted. That stuff needs to be usable inside that. I'm not going to get terribly into the network and the encryption from point to point. Please don't misunderstand me on this. I'm just saying that this stuff should be shareable. Sound good? So we've done some changing to it. I could walk you through the basics of the storage, but then they started doing stuff like post-processing, overlapping, structured reporting, the concept of, I got an image. The image doesn't have text in it, right? So I need to preserve a lot of information. We'll talk about the concept of an image and header here in a little bit. But could I, or maybe if I need to write on that image itself, could I do that? Well, yeah, you can. You just take one image, overlay the text as an image, and make a third image. And that's what they're doing with overlays and post-processing and what they call structured reporting. Structured reporting draws shapes on it. I know that might not seem like an important thing, but if you got a piece of software or an AI that's reading like a mammography, it's hugely important because that stuff looks bit by bit and pixel by pixel and finds little things that doctors may or may not have noticed, right? So that's what we're doing here. So moving along here, let's talk about the basics of how to set up DICOM. And I want to cover this prior to going through the whole lab portion of this. And yes, we are going to do the significant lab portion on this. And that is there's three things that if you're going to write down, these are the three things you need to write down. All machines in DICOM are going to have what's called an application entity title, or AE. We just call it a AE title. They're going to have, of course, an internet protocol address or IP address, and then we do use TCP IP. And because we're using TCP IP, another thing that we're going to have is we're going to have a port. And I can explain this. An AE title is like a name, right? An IP address is like a street address, and a port number is like an apartment number. So if I want to send data to a piece of software, I give that software, notice not the machine, the software, a name on the machine that's hosting it. That machine has an IP address. It's like a mailbox. It's like an actual physical address. But that software also lives in an apartment at that address. We'll call it a port number. Now, if you can get these concepts, you will have the basic working blocks required to know DICOM. How does that sound? That's just three things, right? We're going to be referencing those a lot. So I really want to talk about this users and providers. There are things SU, SCP, but I really want to get into the concept of roles. Think of this more as a piece of software and less like a machine. For example, right now, in fact, actually, let me show you. This is my laptop, right? Don't necessarily need to show you that. Here's pieces of software that I'm running. So how many roles am I doing? I mean, I can do more than one thing at one point in time, right? And machines are capable of this. So don't think that a DICOM software is a machine. Think it's a role. It's a software performing a task. It'll be a lot easier to understand at that point in time. Here's something that your X-ray departments are going to talk all about, the session numbers. Access being the root on that. How do I access this image? So the accession number, right? That's very important to everything that your radiology departments are doing because that's how they index these things. That essentially is their working list of what they're doing that day. So you need to know about accession numbers as well. And then that gets me to the header and the image, and I've got that down here in this lower corner. And I know it might be a little hard to see, but the DICOM file itself, the whole file itself, is two things. It's text describing the image and the image itself. The image is usually just a JPEG. Now, I don't know if you all have ever looked at something called metadata in JPEG, or if you actually look at the details of JPEG, it actually tells you when the shot was taken. You know, sometimes it tells you what machine it was taken on. Well, that's about it. That's not enough information for a medical record. What we need to know is, you know, patient name, patient birth date, you know, maybe some identifying information about the patient, the doctor that sent them, the doctor that needs or reads the study, you know, the facility, the machine settings, the study information. Pixel information is how to display it. There's a lot of information on there. And so the headers themselves can get quite big. We're not going to go further into the headers because I got too much to cover. But that being said, I want you to just think of it like this. Thought of a great way to explain it. Let's say I got a picture. I want to describe the picture. So I write on a sheet of paper all the descriptors that I want on that picture. I might take 20, 30 sheets of paper. Doesn't matter. And then I take a stapler I put my paper on top of the image. I take and staple it together, and I call it a DICOM file. There you go, right? You want to know about the image? Flip through all the sheets of paper, read, right? It's just that simple. Doesn't have to be complicated, right? So let's move on. I'm going to go back to talk about the roles briefly because I sort of glossed over something that is important, and that is the service class user and the service class provider, SCU and SCP. Here's a funny thing. A user sends a file, a provider receives a file. Keep it simple. Don't overthink that one. User sends, provider receives. Now, let me ask you a question real quick. Let's see how good you are about remembering the stuff we talked about. Since these are softwares that are performing roles, can I do both on the same computer at the same time? Essentially, yes. Now there's some that's an oversimplification, and there's some people that might get concerned about, well, you got to send and then you got to receive, and I'm not talking about the order of transferring of data or the complexity of that. I'm talking about the simple perception from you sitting there. It can be a user in the case of a modality like ultrasound that doesn't need to receive an image from anyone. It just transmits, right? It can be a provider like a printer. That's a print server, like those early print servers. Never really sent a file out, but it just received files, right? And then printed to its attached printer. Or it could be like an archive, where I'm going to send it to you. Great, that's a provider role, right? And then I'm going to request, hey, could you send me an image? And then it's going to flip to a user mode and send to me, right? And so it's important to understand that this is how things work. Here's why. Because when they're describing to you in the conformance statements in the software's manual, they're going to use these terms, SCU and SCP. And they want you to be able to follow what they're doing with the data. You see what I'm saying? Are we getting too deep? Feel like we've got a good foundation? Yeah? Ma'am, how can I help? Yeah, well, and that would be a possible way to look at it. But the funny thing is the concept of creating is more true to the modality and less true to the archive, for example. So I just think of it as, send and receive, but however you want to perceive it to keep it straight in your minds. Yeah. I don't really think there's any particular right or wrong on that one, just as long as people get the concept. So here's what I want to do. And here's where we're going to step off the concept of having a PowerPoint. Let's actually build this thing. Let's do it today, right now, in fact, as a live lab. You ready? I am. I've downloaded my software already. How about that? Yes. You are going to have to figure out how to download software. Now I'm going to give you a warning here. You ready? This is going to work really easy because I'm using the same logon, the same laptop. I'm actually going to pass a file between a server and a client that we're going to set up together. So the big question is, well, why is that going to work? Well, I don't have to worry about a firewall because I'm not really leaving the machine. But should it still work? Can I run a user, an SCU and an SCP on the same machine? Well, yeah, actually, I'm sort of doing it right there. Okay, so let's take a look at this. First thing I want to do is I want to get, well, actually, I jumped ahead a little bit. Deep breath, dive in. Boy, I was already off the board, wasn't I? Okay, moving along here. Let's go to the server. There's a lot of DICOM servers out there to learn on. For years, I've used this one. It's free. Is that everyone's favorite four-letter F word, right? Free, okay, yeah. Okay, we'll leave the dirty jokes aside. Let me go ahead and point out this. There's the place you can download it, this image systems. I'm gonna make this easier for you. its name is ConQuest DICOM server. So I'm going to go to the web. Let's go to the web. ConQuest. Oh, I got my caps on. I still got my caps on. We're going to type ConQuest DICOM. I didn't even get the whole thing out there. And notice here it gives me a link. I'm going to click on that link. This is actually the correct website. The one that I referenced on the bottom is actually the next one. This will take you to this hosting people that are hosting the front end of this. You scroll all the way down, it tells you what it can do. You go to the download and it takes you to the same page anyway, right? So up top here is got a whole bunch of provisos of how it was created, some demo stuff, and this is basically how you put together a web page in, pardon my saying it, 1998. But you scroll all the way down here, and there's the most current file. You go ahead and you click on that, and it should download that file, and I don't know if it's downloading that file right now or not. Whether it does or does not is immaterial to me, because I've already gone ahead and accessed that file. Now I'm going to tell you where I put it. And at risk of showing you everything on my computer hard drive here, I'm going to recommend that you take this file and drag it into a folder marked DICOM on your root. C drive created a folder called DICOM. Here's why. This program was old school Linux and pretty much just about an evolved version of Unix. I'm surprised it has a GUI. Okay, and in fact, actually, it doesn't have to have it. By the way, for those of you that know what the term GUI means, you can click on a mouse, right? So once you unpack and unzip this gigantic file, or well, it's not gigantic, it's probably about 30 megs, it'll give you this thing right here, which is the DICOM server. You go ahead and click on that, and I've already got it up and running, and it'll take you to this, which is the actual server itself. Now, it might originally take you to the configuration file, and there's a lot of things here that you could be very concerned about, but one of the things I like to be concerned about is right here. Does everyone see that, where it says install server as an NT service? What that's doing is that's installing this so that this will start up with your machine. I find that it runs better if you go ahead and install it as a service. It becomes a process running in the background. For those of you who've studied computer operating systems, you'll remember that a service is essentially a process that is a part of Windows. So it becomes a part of Windows. After you're done with that, I'd like you to go over to the installation files. I'd like you to verify that your TCP/IP installation and your database installations are correct. And that's just as simple as hitting a button, and then it gives you a readout here. And if it says the successful test at end, and can any of you even see this? Okay, well, if you can, fantastic, and you've got great optometrists. Okay, so moving along here. Sometimes that database doesn't like to install. So you might find that you have to reinitialize the database. It'll go ahead and it'll create you know, a log for each one of the sample images. It does have 2 sample images that come with it. Also, one of the things I like about the server is it has embedded in here well, it's supposed to be a image, and it usually does display, but for some reason I'm not able, there we go, to display the images. So this is broke down by study. This is the series. Does anyone know the difference between a study and a series? Let me help you out with this one. Let's say I go to the doctor and I say, oh, I've got a what I think is a messed up back. I actually have that. That's why I've got the cane. Okay, so the doctor takes an x-ray and goes, yeah, I want to send you to MRI. Now, could you go over across the clinic to the MRI? So he took an x-ray, said there was a problem, send me to MRI, right? How many times did I visit the doctor? Technically, no, I went once. Thank you for jumping out there, though. I appreciate that one. So I can create different series. Notice the series has a modality. The modality is the type of device that's taking the image. Notice the type of device that's taking the image is the CT, right? So I might have one that says DX for my X-ray, And then I might have one that says MR for my MRI of the back. But they will all be different series under the same study. Notice this is the patient name, head exposure number 2. There are 2 images. If I click on them, I do see those 2 images. They're pretty much a basic display of what you would expect for some form of a workstation. But you know, it's got something for us to use. Let's go over to the server status over here. Notice that over here I've got a log. I can do things like kill and restart the server, and that's going to go ahead and give me a log where it's going to stop what it's doing, and then it's going to boot back up, and it's going to say, yes, guess what, I'm running. Now, anything that I do in here is going to show up as a log. Now, there's some options here in the log. There's like debug. Debug gives you, and it literally says right here, more information. Just in case you were confused, you get what debug does, right? Gives you more information, right? So anything that we do here is going to show up in this list. So let's look at this one. This is probably the last thing you want to look at, and these are the DICOM providers. And the DICOM providers here are the pieces of software that I should talk to. These are the SCUs and SCPs that I should talk to. This thing is a little finicky. It uses essentially a notepad text file. So the question is, well, how does it know that these machines are different machines? Well, let's go to this Ginkgo. I'm going to change this. Well, actually, let's just enter a new Ginkgo. I'm going to give it a name Ginkgo because, and I know this because we're going to be creating this software. I'm going to use the tab, and I'm going to go over to an IP. Now, how do I get an IP? Does anyone know that one? Use command prompt. Let's do that. IP config. There you go. So this is my wireless adapter. There is my IP right there. I can copy that. Let's see if I got that. If I don't, I will remember it because I've done this. There we go. Did I take an extra space in there? Spaces are important. You want to make sure that you tab. Notice how I tabbed and made sure that it is in the column. That is the finicky nature of this program. It wants you to put tabs in there, right? So just keep that in mind when using this. I'm going to give it a port. Let's give it a different port, 2221. Why? Why not? Because it's different from the one I entered earlier. And then I'm going to tab over to this, and it's going to ask me, do you want to send it in any specific type of image? And UN is uncompressed, UN is uncompressed. Now, here's where a lot of people have mistakes. They just sort of leave the cursor there. How does this machine know you're done with that line? Well, there's something called carriage return. Carriage return is enter. You got to enter. Once you move that cursor down to the bottom by hitting enter, it put in there. Now keep in mind, even though we are reading this, there are invisible characters in here. There were some tab characters in there, right? And then there was this return at the end that knocked us down to the next line. I'm just going to go ahead and save this list. Yes, we're going to save that. And it should work. Actually, folks, as weird as it sounds, that is the information that I'm going to use for my client. I know a lot of you all are like, where did these numbers even come from? Well, I know the name of the software that I'm going to use for my workstation is Ginkgo. We're just going to call ours Ginkgo. Okay, it's I know this is my machine's IP address, and this is just a port. I could have grabbed any port I wanted to. I basically did an inverse of this. And I know 2221 is a popular DICOM port, so I'm just going to use that one. So this is my workstation that we're going to set up here in a little bit. Well, where do I find this software's AE, IP, and port? Well, first off, let's start with the easy one. IP, what machine is it running on? Same one, right? So it's running on the same one. If you click here in configuration, notice here it says AE title. If you can see that, that says AE title. And then here's my AE title is ConQuest SRV A lot of people sometimes put SVR because server, I guess that seems a little bit more comfortable to them, but hey, no, not to this programmer. They like SRV, right? So that's the default. And then it's just number one. And then for the port, notice the port is 5678. Yeah, okay. So that's basically a face roll. They basically put their fingers down and went 5678, why not? There, done. It could have been anything else, 3321, for example. So anyway, what I'm going to tell you is this. We've installed our software. We've installed it as a service. We've verified all of the setups. We've verified there's something in the database. There is something in the database, right? We've verified that we've got the client software set up. Let's do it on the client software. Let's talk about that client software real quick. Which one do I recommend? I recommend Ginkgo. I like Ginkgo. I used to use a software called KPAX. They made it a little harder to get KPAX, but both KPAX and Ginkgo I'll mention, they're free. KPAX you have to sign up for, and you have to get onto their newsletter, and they'll give you the free software. If you want, after we're done, we can just sort of run through a little bit of that. But I find that Ginkgo is just easier and just a lot more inherent. Plus, unlike the zip file that you have to unpack into a specific folder, Ginkgo comes with an MSI, it's a Microsoft installer. You can just download it and run it. So it installs just like your web browser would, or any other piece of software that you might get over the internet. So let's take a look at that. Where do we go for, oh, did I not do that right? Let's go over here. Let's go back to this. I guess I'll start at Google just to make sure that everyone's familiar. This is where you'd normally start, right? I'm going to put Ginkgo, and yeah, not Ginkgo biloba, Ginkgo CADX. It's important for me to point out what CAD is, computer-aided detection. Remember when I talked about that AI software reading bit by bit? That's a CAD system. So you want a CADX. This is free. It was born in Spain, so if you see some Spanish, hey, that's why. Notice it's got a downloader here. You can just go ahead and hit the download, and it should download there. I've gone ahead and done all of this already and ran the installer, and there you go. By the miracle of television, we're already installed. How does that sound? So yeah, that was fast. Yeah, that was good. I wish they all installed that smoothly. So Ginkgo views images. Here's an image. I'm going to go ahead and I'm going to remove this image from the database. That was my test from last night, by the way. I've just gone ahead and I've deleted all of the images that we had in the Ginkgo CADX. So what I'm going to do here is I'm going to show you how to set up Ginkgo. Ginkgo, you go to Tools, and you go to Settings. Notice here you have logs. That's just like the server. Well, I got a log right here, right? So you can see both from the client end and from the server end how the communications go. Let's go ahead and click on Settings. Now, if you'll notice here, there's something called DICOM nodes. Now, a node is essentially a server. Let's just keep it simple. Node is just a fancy way of saying I've got a server, but node became a term when we started moving our servers off of our local area network and started putting them on the web. And once they became things on the web, server wasn't really the best way to describe it. So they sort of evolved the term to node, but there you go. So notice here, this is Ginkgo, and then it's got this funny IPv4 thing. And what it is this is a programming thing saying the last bit of my IP. Notice here it's got IP4. If I change it to IP1, it turns to my first bit of my IP. And if I just did IP, I wonder if it would. Yes, it does. It just gives me the whole name of my IP, and I'm not going to do this. I'm going to go ahead and go just with Ginkgo. It's almost like I knew it would do that, isn't it? Okay, so we're going to go ahead and keep this name simple. Remember, I changed my port. We're going to give it a port. Now, I want to tell you about ports. Why didn't I give it the same port as the server? Well, remember I told you software lives on the machine in an apartment. These are singles. These are onesies. These are efficiencies. No one's doubling up. Okay. Software does not, they have to have their own port. Okay. That's how we tell which one is where. Okay. Well, if you've seen an apartment, you understand this, right? So, okay, fine. Everyone lives in a onesie. We're moving along. Notice here it's got the actual node. I'm going to go ahead and click down here. Notice you could have clicked new. I'm going to delete that. We're just going to go ahead and add a new. Notice I go to new here and it asks me for an ID. Now here's what's interesting. This ID could be anything I want to call it. It could be whatever I want the person using this Ginkgo CAD to see. I'm just going to say ConQuest. Why? But I could say this, come to think of it. Here's what they'll probably call it in your facility. They'll call it PAX, which is a wonderful blanket term for it's an archive. That's a really nice oversimplification, by the way, because anyone who works on the archive will tell you no archive now is just one machine. There are load balancers called, storage commitment servers, and there's all sorts of other magic that's happening back and forth. And the truth is everyone doesn't have to know it's something called a storage area network, and you don't have to go into this big spiel to your customer. You can just say that's PAX. It's where your images are. Keeps it simple. But let's tell it where to go for that. ConQuest SRV1, if you remember correctly, not SVR, SRV1. If you remember the host, 172. You can go back over here, 20.24.10. That's this machine. Port number, remember we did 5678, not 2221. Who's living in 2221? Ginkgo is, right? And we're onesies. No, you can't use that. So notice here we've got some other things here. We've got a URL. Yeah, you can do this over the web. This is a node, not a server. It's prepared for you to use a website to host the back end, which might seem crazy, right? But what if that website's Amazon? And I know what you're thinking. Why would I give Amazon all my medical images? Yeah, if you have Epic, you've given Amazon all your medical images. Because guess what backbone they use? Amazon one time jokingly said something. They said that they created a network that was big enough to store a lot of data. It was the biggest network that they would have, and it was scalable. And that was what was important, is that they could duplicate it and scale it in multiple places. And then somebody asked, well, how big can your archive get? And they went, the data in the world, we can hold all of it. And they meant it. Let's just hit test connection. If you're using Waldo, no. Okay, let's accept. If you want to use, Waldo, we're just going to do a move. There we go. Accept. Let's double click on that. Make sure it saved my things. Test connection. Connection successful. Quick to the archive. Let's go back over here. We did something. We sent it a message. Look at what it says here. Ginkgo talked to ConQuest. It used this format for sending the data. It said C echo. C echo is a DICOM command. It's sometimes called a DICOM ping. Sometimes it's it's a handshake. It actually goes a little further than ping. Ping is a great handshake. It says, hey, send me this packet back. Do it 4 times. Great. The DICOM software is actually running as a software. It's layer 7. So there's a lot of things going on. It's more like, hey, check to see if I'm on your list. Make sure you understand my AE. Make sure you understand my IP. Make sure you understand my port, and then send me back a confirmation, please. That's a little bit more detailed, isn't it? So that's what we're doing here, and this is confirmation of that. Well, guess what? If I've got this successful, then that tells me that I can actually query things from my archive. But notice it doesn't say that my archive can flip roles and send back to me. I'm going to go ahead and apply and accept. We're going to do something called a query retrieve. Now, query retrieves are exactly what it sounds like. A lot of people call it is a DICOM move. or pull it down from the archive. Those are terms you might hear people say, right? Pulling being I'm reaching out for information, and pulling it in, pushing I'm just throwing it to you, right? And so often the terms pull and push in DICOM are relative to where your butt's sitting at the time. You know, if it's going away from you, it's a push. If it's coming to you, it's a pull, and it changes based upon who's saying it and where they were sitting, right? We're going to go ahead and we're going to pull down an image. But I love the fact that this thing says query retrieve. We're going to do two things. The first one is a query. What do you got in your database? It's going to give us some information, then it's going to stop that communication. Let's do that. I'm just going to say, hey, show me everything. I'm going to leave everything blank. I'm not going to tell it what to filter for. I'm going to hit enter. It's going to give me a warning and go, you realize these archives are freaking large. And if you ask for everything in it, it's going to be a while. We know we got two things in our archive. Just go ahead and click yes. Notice here it gave me some information. It says patient head X2. Notice this is not on the server software. This is on the client software. This could be on a different machine. All we had to do is change the IP, but have that machine with that IP on the network able to see this one. Essentially, at this point in time, folks, we've succeeded. We've created the lab. Let me go over to the software over here in the server and I'll prove it. Notice this. Ginkgo requested my software. I'm going to do something here. I hope that the recording does this. Those of you that have been my students, you know I love doing stuff like this. There we go. Calling title, calling application title. So the AE title that requested it was Ginkgo. It called, it was talking to me, the server. Notice I'm on the server, right? Yes, this is some stuff that tells how it was transferred, and you can look this up in something called a conformance statement, and we'll talk about that later. But just notice that this is just the information as to how it was sent. More important, notice it's searching for a study. It did a C find. C find, C being a command that we're having it do. By the way, there are two different types of commands, C types and N types. They call it composite and normalized, but really I just remember it as you've given a person a command, they're doing something. Normalized is the software is doing something. So if you see an N type, it's software requesting things. And those of you that know DICOM know I'm making some pretty big glossing overs right now. That's okay, because functionally what I'm telling you is about an 80 to 90% hero. Let's move on, right? So C find, and it sent one record, and then it stopped the communication, right? Let me zoom back out of this. Where we zoom back out? Shoot, I lost my my zoom. There it is. We're going to zoom back out. I'm going to minimize that just in case I need that again. We're going to go back over here to the Ginkgo CAD. We're going to see that this is here. I have to actually download it. I can expound upon this and it'll show me the images. Over here, it actually has a button that says download. I can download one or the other, or I can just double click on it and I want to say that it does it. So let's go ahead and download it. It told me, hey, do you know that I've already downloaded it? The reason why it said that is because I double clicked on it sort of instinctively. And there you go, there's image one. Here's image two, wait a minute. Where's my 1, 2, where is it? There we go. Right, left arrow on the keyboard. Image 1, image 2. I got my two images. Essentially, we created our network. We've passed an image. We're looking at it on a workstation. The only thing that's stopping me from having two machines is the fact that I did it on one machine with the same bits of software running on this machine under the same login. You could go at home and do this. And I really want to stress, that's the point of this presentation. You should go home and do this, because this is what will teach you how to make this work. And the more you know this, the more you'll be able to adapt. So, you know, at this point in time, I really want to make sure that I get through the rest of the presentation. Not that there's a lot of slides, but there's some things that I want to show you that additionally. The modalities. Let's talk about a modality. I want to say this is a screenshot or something that I took from a ultrasound user manual. I want to say Acuson. This is what their menu looks like. See commonalities? The three big settings, AE, IP, port. This is for the image storage. If you look up somewhere on there, you will see its settings, but this is so that it will talk to an archive. So this is where I might put PACS, right? And notice here you got ping and echo. Ping, notice ping is on IP, but echo is on DICOM AE title. What do they mean by the differences between ping and echo? It's close. You're thinking one's for, let me put it this way, ping, IP, just like the IP ping command at command prompt. Echo, remember when we did an echo, we did the test successful? Echo is actually that DICOM validation. Remember the C echo command, right? And notice this is the port number of this remote. And so this is how they set things up. Now, I mentioned storage commitment. I mentioned here also in this this slide, MPPS. There's a lot of other settings that you're going to find important, and really all the ones up top here are what's important. We've got like a store, and most of the storage here is just going to be like a simple store. They may have just a simple machine that you dump it to, but then they might have something called storage commitment. And with storage commitment, I say, well, I'm going to send it to this machine with this priority, but then I've got these machines as secondaries. I can change a path to go to my archive. Does that make sense? That's the basic structure. Again, I'm oversimplifying something. I'm glossing over a lot of different settings, but the truth of the matter is think of it this way. I've got more than one server I can hit so that I can dump information to it. Now, here's what's really going to blow your mind. You ready? They use the same archive on the back end. So you got multiple front end machines that you can dump information to that have a separate network. It's usually only fiber going to a really expensive hard drive. We'll keep it simple, right? Where these machines can all talk to the same hard drive. They keep one database on that same storage to where they can update, or they keep multiple databases and they update each other. But it is entirely possible to use a whole separate network as a storage for a DICOM network. That sounds weird, right? That's what storage commitment is. MPPS, this is important because a lot of times people are going to want to work with HL7, and work lists are what's called your RIS, your radiology information system. That's your scheduler, right? That's going to be where your session numbers come from. The work list is that you go to the machine and go, can I have my next patient? Yeah, sure. You got these 3. There's 4. You got these 4. And they're the ones that are scheduled next. And then you just select the one that matches the wristband and go. You didn't have to enter any of the patient data or anything like that. You know why? We don't want nurses and doctors typing. You think that their prescription pads are bad? Do you know they typo like 40%? I shouldn't say typo. There's a concept of normalization. That is to say that all dates should be in this format. Let's just keep it date. Simple, right? How many different ways is there to write a date? 4-digit year, 2-digit month, 2-digit day? Is that the same thing as 2-digit month, 2-digit day, 2-digit year? To you, yes. To the computer, no. I don't want them typing. I want them clicking, right? Click, load that patient, scan, match, good. Scanning the patient, you know? That's what I want them doing. It's faster for them, and it eliminates the typos. And it's not even a typo, it's just a formatting issue at that point. So MPPS, yes, I know, down to my last 15. MPPS, this is a fun thing that a modality can do. Since I got a patient record, and let's say I've got some modalities, I'm going to pick on MRI, who might take, say, for example, an hour to do a patient. Is that important to your housekeeping? I mean, when you grab a patient and transport them down to MRI, actually it is. Here's why. 45-minute window, that's something important to housekeeping. How about I ask a better question? Is that important to the patient's family who shows up and goes into an empty room and sees a housekeeper and goes, "Where's dad?" The answer they don't want is, "Well, I don't know. I guess I lost your father." Oh, hey, you got an extra one, right? No? Okay. You see what I'm saying? How about this answer? Ah, your father just went to MRI. You know, it's estimated that it's going to take another hour for the scan to be done. Do you want to go to the cafeteria or the break room in the time being? How do I get a hold of you when your dad's back in the office, not in the office, in the, force a habit there. You get the point. And then printing, we've talked about printing. Let's talk briefly about troubleshooting. You've seen a lot of the things right now. That's fantastic. So let's just gloss over the things we've seen. We've seen ping. We talked about it anyway, right? I'm not going to cover networking pings. If you don't know what networking ping is, catch up. Moving along here, DICOM Echo. Seriously, if you do struggle with ping, my suggestion is go to YouTube. They'll literally just show you step by step. Open this, type this, get this, right? DICOM Echo, we talked about that. That's the validation, right? Server status, okay, and debug logs. I'm going to sort of clump those together. Remember, we had debug logs on both ends. We can look at these logs back and forth, and they will tell you some important information. I'm going to show you these next things here. The DVTK network analyzer. Oh, I love this. So there are a free set of tools. Let's go ahead and find where these are. Where did I do it? There it is. Fantastic. This is a what's called a sniffer. It uses a switch. For those of you taking notes, I just came back from the optometrist, by the way. They fixed a problem with my bifocals. Now I can actually use them. Okay, so this is a TP-Link model SG105E programmable switch. I bought on Amazon for like 50 bucks. It does VLANing. If you want to put a little bit of money into some hardware to go at home, you know, and build a network with your laptops or computers, you know, you can hardwire into something like this, and you can go through there again, YouTube, step by step, how to do VLANing, how to learn things. These are really great switches. What's really good about this switch is I can create a mirror port, and I can say, okay, everything that's going to this port, I want also sent to this other port. All of them, yeah, or all of them. So there's a concept between a switch and a hub. A switch sends data where it needs to go. Well, that's nice. A hub is just yelling. It's just going to yell the information to everybody, which is not bad when you've only got 5 people, right? But it's really bad when you've got 5,000 people and they're all hearing everybody's conversations. You were on the expo floor. You get my point, right? So yeah, it's loud. Switches make it quiet. Problem with the switch, if you don't have a programmable switch, you can't make this work. What I'm going to do here, notice it's got a target IP. It's got, well, let me zoom in again. Where's my magnifier? Got a target IP. You can go this machine, listen to this report, or listen to this port. You can tell it to go ahead and start capturing. It'll capture a DICOM association. It'll say, hey, I've got this DICOM association, and then you can literally just pick apart the exchange. And this is really important when you've got that stubborn machine that will just not communicate. Now, here's the strong warning. You ready? This switch has something called a MAC address. That is how switches work. Everything has a MAC address. It's like a fingerprint. It's a fingerprint to the network interface of your machine. If your network security people are worth any of the money you pay them, if, not when, if you set this up on a network,